Hello everyone and welcome to another video. So today I'll be showing you how to do image compression in R, using the principal component analysis technique. So this is going to be a very good demonstration to show the dimension reduction property of principal component analysis. Since any image is basically a matrix that is represented by the RGB color. The principal component analysis can be used to reduce the dimensions, to produce new images that will, retain the same qualities but in smaller size. Okay, so we're going to see how that is going to happen using this using R program. Okay, so let's just quickly go to the R console. All right, so this is our R console, and as you can see, I've already written the code. I don't want to, sort of waste time in typing and show you guys how that can be done. If you ever want a video for me to code from scratch, I'll more than happy to do that. Just let me know in the comments below. So I'll just quickly explain you the code. So this is basically the function name image compressor, and we have three arguments. We're gonna take an image from a current folder and compress it and put the compressed image in a new folder with specifying the number of components we want in that particular folder. Okay. So yeah, this is pretty. I mean, the logic is quite simple. Here we have an empty vector, which we have list of files, and for all the JPG images, we're just storing that. Just making sure that all the JPG images in our current folder get stored in this vector. All right, and then here we're starting the principal component analysis process where we're using the image library. We're reading the you know the yeah. For this, one more thing, you need to make sure that the JPEG package is activated. I have already activated the package, by the way. You just need to go here, type in JPEG and get that activated. Okay, and right, so here we have split the components, like basically RGB. I mean, we split the matrix, the image matrix to RGB, and we're calculating the components using the PRComp, function here, and then we're storing all those components in a list called rgb.pca. Then we're compressing the image, and the final image we're writing it in the final path. Okay, we're using the right JPEG. We're saving that using the right JPEG function, and you can just ignore this. This is something that I thought might be fun. Like you can just like if you can just delete the source file, because once you've compressed it, why do you need the source file, right? The non-compressed image already has a lot of space, and in the compressed image you have the same image but with a smaller size. So why do you need the original image? At least that's the logic I have. But you can just, I mean, if you're copy pasting this code, you can just remove this part. That's not a issue. All right, and then we're compressing the whatever images which we have. We're compressing the last image in the folder with different clarity. Right, we're specifying the number of components that are there. Okay, so you'll be able to see that once I run this. So this particular function which I've just created, I've already specified the from and to folders. Let me just show you those. From, right, so this is the original image. This is a fake ID card which I created for Tableau license. You can just ignore that, but just look at the image. Look how it looks. And I'm just going to, okay, instead of 7, let's just see how it goes with 3 components first. All right, so 3 components. All right, here you go. So this is the one with 3 components. Okay, obviously nothing's visible, but if we try with 710 components, 710, okay, right, so 710 components, you can see that the image is much clearer and the size is also really small. Okay, so this is one advantage of principal component analysis. It's just a practical way. Obviously, the in applications it's not designed like this. This is just a very sort of basic function which I've created. They have much robust functions there. But this is the generic understanding of how principal component works, right? For image compression. So I hope this video was useful for you. If you found it useful, just give it a thumbs up and do subscribe to my channel for any further. I'll be posting a lot of data science content. And yeah, until next time, cheers.